This is Chapter 11, Section 2, and it's on water use and management. The objectives are going to be to identify patterns of global water use and to explain how water is treated so that it can be used for drinking. Also to identify how water is used in homes, in industry, and in agriculture. To describe how dams and water diversion projects are used to manage freshwater resources. And then finally to identify 5 ways that water can be conserved. So water use and management. When a water supply is polluted or overused, everyone downstream is going to be affected by that. So obviously we want to limit the amount of pollution that's going to occur upstream. And also a shortage of clean fresh water is one of, if not the biggest, one of the biggest environmental problems in the world right now. The World Health Organization estimates that you have about 1 billion people that lack access to clean, reliable fresh water. This is going to be a map of how do we use all the water in the world right now. I'll kind of direct your attention to the far right where the world average, where yellow is agriculture, blue is industry, and green is residential. Most of the water in the world is going to be used for agriculture, about 70% in the world. And then the next highest is use in industry. Industrial use of water, the largest one's actually going to be using to cool down power plants. So whenever you have power plants that are generating energy, the generation of energy creates a lot of heat. And to cool down those power plants, you'll circulate cooler water through the power plants where that water can take some of that heat from the power plants, and then you can then discharge that water or then kind of recycle it back through the plant as a way to cool it down. And then you have residential use of water where people taking baths in it, dishwasher, washing machine, maybe irrigating, using it for their lawn or something. And so what you'll notice is in areas of the world that are more developing countries, kind of areas in Asia, Africa, some areas in Latin America, you have agriculture as your main use of water. However, once you get to more developed countries like in North America and Europe, that balance shifts where industrial use of water becomes the main use of that water and agriculture becomes more of a secondary use. Also, especially in North America and even in Latin America, you get a lot more residential use of water. So most of our fresh water that we use today, as I mentioned in the previous slide, is going to be to irrigate crops. In industry is about 19% of the water, and about 10% of water is going to be used by households. And when we talk about residential use of water, just to put some numbers to it and to give you an idea, in America, in the United States, about 300 liters of water is used by each person per day. But if you compare that to India, the average person only uses just 41 liters. And about half of that water that U.S. residents use, only about half of that's actually used inside the home for things like cooking and drinking. And the rest of that's being used primarily just for watering lawns. Which is something to really think about, especially kind of out in the suburbs where you have the nice manicured lawns. They look really good, but are they really the best for the environment? Especially when you consider how much water we're having to use to maintain those nice, perfect green lawns. And this is daily water use per person, so a lot of this stuff here on this table are things we can't really do a whole lot about. Like you got to take showers, and you got to wash your clothes and your dishes, you got to use the bathroom. But, you look at leaks here, leaks account for 36 liters of that water. And then the outdoor total that I mentioned in the previous slide, like those are things that we can do a little bit more to fix and try to control. And that's sort of the goal when you're talking about water conservation, or even things like taking shorter showers, using your dishwasher and your washing machine only whenever they're full of clothes and full of dishes, taking shorter baths. There's high efficiency toilets that you can install. So getting into the idea of water treatment. Um, Potable water is referring to something that's suitable to drink. Um, and water that's suitable to drink is water that's been treated to remove a lot of elements like mercury, arsenic, and lead that are going to be poisonous to humans. And some of these elements are actually in our groundwater. However, they're at a concentration that's much lower um, than than what's going to be found in the surface water. Um, that's going to be more heavily polluted, through agriculture and industry. A pathogen. A pathogen is just basically it's really anything that can cause a disease, and it's usually referring to something like a virus or a microorganism like a bacteria. And where pathogens are going to be found, how pathogens get into waters is going to be through some sort of sewage or animal feces. And fortunately, we have water treatment methods that can remove these pathogens. And these methods can be both physical and chemical. And this diagram right here gives the typical drinking water treatment, where the first step is where you just filter out the biggest things, your large organisms, large pieces of trash. And then you go to step two, where you have what's called coagulation. So coagulation, something coagulates. It means it kind of clumps together. Um, so what we do is we add aluminum to this water, and aluminum is going to attract um, bacteria and other impurities, stuff that we don't want in the water. It's going to attract it all together, and it's going to cling onto that aluminum, and it's going to form these things called flocks. And these flocks are going to settle to the very bottom of the tank. So these are the flocks down here. And then you're going to go to the second filtration. In the second filtration, you kind of run it through what you would think of as a more traditional water filter. So kind of like, a similar filter that you find for our groundwater when we talked about in the previous section, whenever water goes from the surface, through the layers of the aquifer to reach, to form the groundwater, where you have your sand, your gravel, and then your hard coal that can start to filter out some of those impurities. And then step four is going to be chlorination, where you start to really remove a lot of those pathogens. Because if you add the right amount of chlorine to the water, you can not really harm humans, but you can actually just kill the bacteria and the pathogens that you don't want in your water. And then finally, or second to last, is you're going to have aeration. And aeration is more of a cosmetic thing, or just something that we do to help make our water smell a little better and improve the taste of it. Because when you add air down here, that's going to help to release other gases that are in the water that cause the water to have that sort of, maybe a bad smelling odor or to taste really bad. And then some extra treatments. The biggest one is going to be fluoride, which fluoride is something that's in a lot of your toothpaste, in really most any toothpaste, and it's in there because it helps prevent tooth decay. So some communities actually will add fluoride into their drinking water as a way to help prevent cavities in that community. You can also add sodium compounds or lime that can help soften hard water. So hard water is referring to water that has a lot of high concentration of minerals. So if you add sodium and lime to that hard water, you can help to remove some of those minerals so it doesn't taste as kind of chalky. Um, and then you can store that water into storage tanks for homes and businesses, into your water towers. Okay, so uh, kind of already talked about this. Industrial water use is about 19% in the world, and industrial use is talking about using water for manufacturing goods, disposing of waste, and also to generate power. Okay, we talked about this with the power plant cooling system, using the water to cool down the power plants. Um, uh, Agriculture, the reason why it accounts for about 67% of the water use is because, we rely on plants for much of our food, but also plants just need a lot of water to grow. And the process of agriculture, we're trying to get that water to plants, really is not very efficient because nearly 80% of that water that we use for plants is actually going to evaporate, which isn't good. Um, Irrigation is a method. It's some way of trying to provide plants with water. So it's plants that are in an area of the world where you don't have as much water. You take water from usually like a river or something, and you build some sort of way to get that water to those plants. Or it can be used, especially just in normal agriculture, where you just maybe it can be something like overhead, high pressured overhead sprinklers is the most common form of irrigation, where um, you're just adding extra water just from overhead, in addition to the normal water that you would get from rain, or other just the groundwater in the land itself. However, this method, the high pressured sprinklers, are really inefficient because a lot of that water, close to half of it's going to evaporate, and it's not even going to reach the roots of the plant where you want it to get. So water management projects. Uh, People, as we mentioned in the first section, people tend to congregate around areas where there's a lot of water, but sometimes people want to live in areas where you don't have a lot of water for different reasons. And so to help give them their water needs, or even to try to control things like river flooding, we have different water management projects like building dams or building those kind of irrigation things that we talked about in the previous slide. And so bringing water to dry areas, also just even creating a reservoir for drinking water. So maybe you have water available, but you want to kind of have this excess water that you can use for, you know, uh, I wouldn't say a rainy day, but a not so rainy day, I guess. And then also you can use a dam, and something called a hydroelectric dam that you can use to generate electric power. And then if you have some sort of dry region, you can create canals that, essentially, you got a river like the Colorado River, and you can dig in these, so you got this big main Colorado River right here, the water. So you can kind of dig off these little side trenches. Think of like your circulatory system, like your main arteries, and then you have these little branching arteries that come off the main one that we can then take, water here, water here, water here, and bring it into areas of land that don't have as much water. However, an issue with this is that some rivers just can be um, you build too many canals on them. So for the Colorado River, about 7 states depend on it for much of their water. So by the time that the Colorado River reaches the Gulf of California, it's actually just running dry. Like there's hardly any water that's ever going to get there. So the formal definition of a dam is going to be a structure that is built across a river in order to control a river's flow. And then a reservoir is referring to the area directly behind the dam that's going to be, it essentially forms, the excess water um, that you use for flood control. So you kind of have this big basin back there, this big open area where, say, you have a lot of extra rain, you can kind of store all that extra rain in that reservoir rather than trying to store all that extra rain inside the river, where it can then flood out of the banks and flood all of these communities around it. Um, and that reservoir can be something they can use for drinking water, for irrigation, even for recreation and for industry. And then you can build these hydroelectric dams that are going to use the power of flowing water. So go to the next slide. You can use the power of this flowing water that's coming through the dam here. So inside each one of these little channels or windows, whatever you want to call them, you have these turbines where the water will push these turbines around and around and around and around, and that movement of the turbine will create electrical energy that you can then transport to homes, to businesses, to power their lights, and whatever they need electricity for. However, there's so there's some good things that can come from dams, but there's also some unintended consequences. Um, Building a dam is a massive endeavor, a huge project where you're going to be displacing people. You may even, it's not even really, you're just going to destroy ecosystems. It's kind of it's not a matter of if, but you just are, and you just try to destroy as few ecosystems as possible and as few species as possible, and try to, I guess, keep the greater good in mind, so to speak. Another thing that can happen is that you can have fertile sediment that can build up in the reservoir behind the dams, and that's because rivers normally, you know yeah, it's water, but inside all that water, floating in that water is going to be a bunch of sediment that's really, really good for agriculture. So whenever you have normal flooding of rivers, so if say you have a large rain that comes down and it floods the riverbank, that flooding of the riverbank is going to deposit all that nice fertile sediment onto the land, um, next to the river. So whenever you build a dam and you reduce that amount of flooding, you're reducing that fertile sediment getting to the land on next to the river. And then also just by building a dam, you're slowing the speed of the river. And so if you're slowing the speed of the river, that sediment that's normally floating in the water will then start to just drop to the very bottom of the river, and even into the very bottom of the reservoir, to where it can even fill up that reservoir completely. Um, and then you can also have dam failure, where this is a little more rare, but dams, just like any structure that we build, there's a certain lifetime to it, where if these dams aren't being properly maintained, they can burst in some areas, and obviously that's a bad plan. Anyone living along that river is just going to be completely flooded out because you're just adding a ton of water to a river that wasn't expecting to have that water. So, because we're running out of water, the idea of water conservation is very, very important. Um, if you have to it costs money to keep digging your wells deeper. It costs money to build pipes to transport water greater distances, and then even polluted water, from agriculture and industry, it takes money to clean up that water, and sometimes we can't clean up that water completely. So the easiest way to kind of get around this is to conserve water. As I kind of mentioned, a lot of, most agriculture, in the water that we use in agriculture, it really isn't done very efficiently. A lot of it's going to evaporate from those high pressure shower head sprays. You even have a seepage and runoff. So any sort of technology that can reduce the amount of evaporation and the amount of seepage and runoff of water is a really good plan. You also have what's called drip irrigation, where you use these small uh, perforated tubes. A perforated tube would be a piece of tubing that has little tiny holes in it that allows small amounts of water to get out of that tubing and then reach the roots of the plants around the tubing. So you can kind of release water at a slow, controlled rate that's just enough for the plant to grow, but not too much to where you're wasting water. Uh, when you're talking about industry, the biggest use, the most widely used conservation practice is going to be recycling that cooling water. Earlier, I mentioned that when power plants, when they're making energy, that that energy creates a lot of heat, and so you pump water into the power plant in order to cool down those power plants. And so if you can recycle that water rather than discharging into a river, you can keep using it over and over again. And then some cities, like Denver, Colorado, have these programs where you essentially pay businesses to save water. And it's viewed as an investment on the city's part because if you can pay a business to conserve water, um, in a way you'll end up saving money in the long term because businesses are just, thinking more about how they're using their water. And then there's a lot of different things you can do around the home to conserve water. A popular thing is what's called xeriscaping, where it's basically where you just design a landscape that uses minimal water. And so that landscape, it can just kind of depend on the area that you live in. Um, but it's anything that's going to require low amounts of water use. And then what you can do to conserve water, I already mentioned a lot of these. Low flow shower head is another one. Low flow aerators in your water faucets. Don't let the water run while you brush your teeth. Um, and then, if you're somebody, if you're a guy or whatever, where you're shaving, then you could fill up your basin of water and use that to shave rather than keeping the water running constantly. And same for washing hands or your hands or face or washing dishes. If you can fill up the sink with water rather than keeping it running constantly, that'll add up a lot over the course of your lifetime. Some really big solutions for fresh water is going to be trying to remove that salt from the water through desalination. So D meaning removing, and saline referring to salt, and then and also transporting fresh water from where there's a lot of it to where there's not a lot of it. And both of these are used. Uh, but they're really expensive. So desalination is something that we can do. It just takes a lot of money and even energy to do this. But a lot of the drier areas of the world, like the Middle East, have some desalination plants where they'll heat the water in order to evaporate the water and leave the salt behind. But for many, really for a lot of countries, that process is much too expensive for it to be a realistic option. And then some countries will actually bring in these enormous plastic bags that are just full of fresh water. So some of the Greek islands that are further from the mainland will receive plastic bags of fresh water that they can then pump onto the islands for those who live there. And especially in the U.S., the idea of plastic bags full of water is something that's being considered because almost half of the available fresh water in the U.S. is actually in Alaska, which is much further north. And then even icebergs, so as I mentioned in the previous section, about 3/4 of that fresh water on Earth is just frozen in our ice caps in an iceberg. So if you're able to kind of melt down those icebergs and concentrate that fresh water, that could be theoretically a possible solution, but um, it's really inefficient and very difficult to tow an iceberg all the way to a community to get that fresh water, though. But in theory, it's possible. Okay, so I'll do it for this section.